Hi, my name is Raktam and in this video I would like to display my project, that is reverse osmosis feedback system. As we all know that water scarcity and degradation is a major growing concern in the whole world. Our earth is covered with 70% of the water, out of which only 2.5% of water is fresh water. And out of the whole available water, more than 80% of the accessible water is not directly drinkable. It requires some sort of purification. The reason behind this problem are overusage, wastage, and pollution. As the days are passing, this problem is capturing more and more places. Today, if the water is available, it is not directly drinkable. At present, reverse osmosis system is considered as the best technology for water purification. These days, reverse osmosis systems are installed in almost every place, such as school, colleges, railway stations, bus stops, airports, government and private offices, and in our domestic houses. But the problem with these RO systems is that they waste a lot of water during purification. For purifying 1 unit of water, they waste near about 2 to 3 units of water. Now, if I consider these places such as school, colleges, railway stations, etc., along with the rejection ratio, that is 1 is to 2 or 1 is to 3, I hope you can imagine how much water is wasted every single day. If I specifically talk about the institutional reverse osmosis systems, they waste lot of water during purification. The picture which I'm showing you right now, I think you might have seen it before. The project is made by taking care of the following parameters. Number 1, can we fit with the existing reverse osmosis system? Number 2, cost effective. Number 3, automated. Number 4, low maintenance. And number 5, low power consumption. Now I will show you a couple of diagrams along with some details which includes existing reverse osmosis system, my modification by relating with an example of implementation, and finally a prototype video of reverse osmosis feedback mechanism which I have implemented in my house. For demonstrating the existing reverse osmosis system, I am taking a reference of wall-mounted RO system. This is the most common type of arrangement used in domestic reverse osmosis system, although the stages and arrangements may vary from company to company and the requirement level of purification. Let me go through this diagram very quickly so that it will be easier for me to demonstrate the further diagrams. From the water source, the water first moves to the outside pre-filter. Outside pre-filter is basically a sediment filter which removes the physical impurities present in the water. The physical impurities can be mud, sand, silt, small stones, clay, algae, and dust particles. Then the water moves to the low pressure switch. Low pressure switch checks the pressure of the water. If the pressure is sufficient to run this RO system, then it allows the purifier to turn on. Then the water moves to the solenoid valve. Solenoid valve is nothing but a switch. It allows the water to flow or restrict. If the purifier is turned on, the solenoid valve is also turned on. Then the water moves to the sediment filter. Sediment filter or inline sediment filter is connected after outside pre-filter. It removes the physical impurities which is skipped by the outside pre-filter. Then the water moves to the pre-carbon filter. Pre-carbon filter consists of granular activated carbon. It removes pesticides, odors, colors, chlorines, unnatural tastes, and organic chemicals. After that, booster pump pulls the water from these filters and throws the water into the RO membrane housing. Due to the presence of flow restrictor, a pressure is developed inside the membrane housing. When the pressure is developed, the water molecule starts to permeate through the semi-permeable membrane or RO membrane. During this process, some of the unwanted molecules based on size, shape, and charge get stuck inside the permeable membrane, which causes scaling and fouling, and some of them are rejected along with the majority of the water molecules through the rejection pipe. And also, due to the pressure, the selection and rejection ratio is about 1 is to 2 or 1 is to 3. After that, the water moves to the UV filter. UV filter kills all the living organisms present in the water. Then the water is stored in a container. When the storage container is full, the float valve present inside the container moves upward and finally turns off the purifier. Before I start explaining my modification, I would like you to take a look of these points. At the end of this video, I will be grateful if you share your opinion about this project. This is the existing reverse osmosis system which I have showed you just now. The arrangement of components inside the dotted box is the modification which I have done. This diagram will be very much simplified when I will relate this with different scenarios and show you with the help of diagram that how this modification can be implemented. For now, consider this diagram to understand that how it works. To implement this system, two storage containers are required. First one comes with the purifier itself for storing purified water, and the second one is required to store the water which is rejected by RO system. I am calling it as feedback container in this mechanism. This container is having three level measuring sections. The first one is maximum level, the second one is minimum level, and the third one is below minimum level. When the system is turned on, the level sensor mounted on the top of the feedback container checks the water level status. If the water level is between maximum and minimum level, then the water will flow from source to the outside pre-filter for further purification. During this time, no water will flow from source to the feedback container. When the purification occurs, the filtered water will flow to the filtered water tank and the reject water will flow to the feedback container via a filter. This filter is placed because RO reject water is having high TDS. By placing this filter, it will reduce the TDS up to some extent. Depending upon the requirement, you can use a filter or a combination of filters to reduce the TDS level. Now, coming back to the feedback container. When the water level reaches the maximum level, the water will flow from feedback container to the outside pre-filter for further purification until the minimum level is reached inside the feedback container. During this time, no water will flow from source to the outside pre-filter. After that, again, when the water level reaches the minimum level, the water will flow from source to the outside pre-filter for further purification. During this time, no water will flow from the feedback container to the source or source to the feedback container. And the process water which is stored in feedback container can either be feedback or can be used for external purpose. On the top of the feedback container, I have placed solenoid valve 4, which is connected to the source. I will explain about this little bit later. The whole process which I have explained you is switching based. The same process can be done by the combination of two-way solenoid valves. In my project, I have used two-way solenoid valves because it was readily available to me. For example, I have displayed some real-life pictures. In these pictures, you can see a common multiple tap arrangement is present for drinking water. This type of multiple tap arrangement can be found in various places, which includes railway stations, school, colleges, and in many public areas where the water requirement is very high. These taps are meant for drinking, but people generally use this filtered water for drinking as well as for cleaning, which increases the wastage of water along with the RO reject water. With the help of this diagram, I hope it will be understandable that how to implement reverse osmosis feedback system. Wherever the RO systems are used, the water which comes out as reject water is drained, and only filtered water is stored and served via multiple taps. To fit my modification, I have divided the area into two parts. The first one is for storing filtered water and the second one is for storing reject water. Earlier, I mentioned that I have set three level measuring sections. I talked about maximum and minimum level. In this diagram, I have left lot of space below the minimum level mark. This space is left so that water can be reserved all the time for external use, along with the feedback process. Now, coming towards solenoid valve 4, we use more water for cleaning than drinking. There are chances where the filtered or purified water tank is full and the feedback tank is below minimum level or about to empty. It may be due to the usage need or maybe due to some kind of maintenance. To prevent this, solenoid valve 4, which is connected to the source, is added. It will maintain the water level if it goes below the minimum level. In other words, it will help to reduce the scarcity of water in the tank by filling the tank from source up to the minimum level or the level which is configured. Rest all process is same which I have explained you earlier. When the water level reaches the maximum level, then the water will be fed from the feedback tank instead of source until it reaches the minimum level. And when minimum level is reached, the water will be fed from the source instead of feedback tank until the maximum level is reached. And the process continues automatically. This was one of the example of implementation. It can be used for different scenarios to save water. Now let's take a look of my prototype implementation. But before that, I would like to provide you some of its specifications. Electrical parameters. The prototype requires 12 to 35 volts with a maximum current of 3.5 amperes to perform the feedback tasks. It is having the water level detection range of 2 cm to 400 cm, which means maximum and minimum level can be set between 2 cm to 400 cm. And also it can take input voltage of 7.5 volts to 35 volts from the reverse osmosis system. If I talk about its abilities, first it provides the status of the purifier. It shows whether the purifier is on or off. It will also show different feedback messages. The purpose of this display is to show that what this system is doing or what task it is executing in real time. Second, programmable water detection range, which means maximum and minimum level can be set. Third, real-time water level monitoring, which means with the help of this device you can check how much water is present inside the feedback tank. Fourth, by default all the feedback processes will be controlled by this system automatically. It will prevent the water overflow. Fifth, manual feedback. Let's suppose that there is no water supply from the source and the drinking water tank is empty. For drinking water, you want to use the water which is stored in the feedback container. By pressing a button, you can feed back the water to make it drinkable. This operation can also be done through IoT. Sixth, temperature sensor, flow meter and TDS meter can be programmed and attached to it. Seventh, can be programmed and attached to IoT. All the above parameters and operating functions can be done and seen via IoT. It is also useful for maintenance purpose. For example, if my temperature or level measuring sensor is not working, instead of messing up with the whole system, by connecting the device to the internet, it will provide me the information that this device is not working. To show the glimpse of IoT functionality, I am using ThinkSpeak IoT Cloud Platform. This is the reading of level measuring sensor which is coming from my prototype. For displaying this, I have added three widgets. The first one is numeric display, the second one is the gauge display, the third one is chart display. Now let me show you my prototype. This is my reverse osmosis system, and here is my prototype which I have implemented. Earlier we used bucket for storing RO reject water and use this water for domestic purposes. But the problem was that it always overflows when we do not have household work. The whole idea is to reduce the wastage of water through an automated cost effective system. This automated system will allow either to use the water which is rejected by RO for domestic purposes, or else if you are not using it for domestic purposes, then the wastewater will be feed back to the purifier by reducing some amount of TDS and without overflowing. Apart from that, it is also having condition based operational functionalities along with the IoT facility. Wherever the RO systems are used, the water which comes out as reject water is drained, and only filtered water is stored and served via multiple taps. This is the system I made with an aim of saving water. If you like this idea and want more information about it, I'll be delighted to provide you. At the end, I would like to request you that please share your views about this project and feel free to contact me. Thank you.